We already have started Chapter 8. Chapter 8 is, in short, our finance section. It's money. Finance is kind of a fancy word for money in a way. And we've already started. We talked about the US tax system. If you'll remember that, we talked about how to compute taxes. We talked about that in section 8.2. So tax information was on your exam there. And also in chapter 8, we talked about things like interest rates, computing percentages of things, discounts, sales tax, things like that. So we've definitely had a really interesting conversation on a lot of money related issues so far. We're only going to continue doing that. And we're going to really get into the details behind interest. What is interest exactly? Well, one possible definition of interest, it's the dollar amount that we get paid for lending money or the amount we have to pay out in order to borrow money. That's one way to look at interest. Basically, when you borrow money, let's say you're borrowing money from someone or an institution, they would like to have had that money. They would have rather had that money themselves so that they could fund things. If you're borrowing from a friend, certainly your friend would like to keep their money and do stuff with it. So if you borrow from someone else, they're going to expect not just the money back that you owe them, they're going to expect some extra money with that as a payment for their time, their service of letting you borrow money. Normally, if you borrow $100 from a friend and you pay them back within a week or a month or something, they probably won't charge interest. Your parents or your relatives, if you borrow money, they probably won't ever charge you interest. But if you borrow money from an institution, if you borrow money from a bank, if you borrow money for student loans, if you pay for school with student loans, you're borrowing money from a financial institution, and you better believe they're going to charge you interest. They're going to want that money back with some extra money for their troubles. So that's one way that you can think about interest, but there's another way that we'll talk about it as well. Now, the amount of money that you borrow is called the principal. It can also be the amount that you deposit, that you put into a bank account that might earn interest, or that you invest if it's invested at a set interest rate. But the principal, for our intents and purposes, is the starting amount. It's however much money you start with, whether you're borrowing, lending, investing. So the principal is just what you start with. Now, the amount of interest you're going to get, well, if you borrow more money, you're going to have to pay more interest, everything else the same. So the more you borrow, the more you're going to pay back. Thus, the amount of interest depends on the principal. It depends on something called the interest rate. And basically what the interest rate is it's hard to describe because there's a couple ways to look at it. But the interest rate is a percent that basically dictates how much interest you're going to be paying back. The longer you borrow for, the more interest you're going to pay back because interest has more time to compound, it's called, or to add up. And then, of course, the length of time. The longer you borrow the money for, the more you're going to have to pay back. Now, what happens is you borrow money, and it could accrue interest over time. Simple interest, though, only calculates new interest based on how much you borrowed at the beginning. Simple interest does not calculate new interest based on interest that has already added into the account. There's an important distinction there. So let's look at an example. Let's say you're going to borrow, let's keep the numbers simple, $10,000 at 5% yearly interest. Now, if you're talking about the simple interest case, $5%, let me type that out. 5% of $10,000 is $500. So after every year, an additional $500 is owed back. So at year 0, you owe $10,000 right at the time you make the purchase. Year 1, you're going to owe $10,500. You're going to owe an extra $500 because you're accumulating interest. Now, what simple interest does is it says after every 1 year, you're just going to keep owing an additional $500. It does not say, oh, after 1 year, now we have to take 5% of $10,500 and tack it on. No, it just says you're going to owe an extra $500 each year. So each year, you just owe $500 more. And it goes on and on and on and on. So you just keep owing an extra amount based on the amount you borrowed at time 0. We're also going to learn in the next section about something called compound interest. And compound interest says each time you update these amounts, now I'm going to charge you interest not only on the principal, but also the new interest that has accrued. That's going to be completely different, and we'll see an example of that in the next section. But for the time being, simple interest is exactly what it sounds like. You only calculate interest on the principal. It's thus a simple system. Now, there's going to be a couple formulas floating around, and we're finally ready to really jump into formulas. What you're going to have on your next exam, you're going to have a formula sheet available to you on your next exam. You can print it off before you take the exam, and you can use it on the exam. Now, the formula sheet, it is very tempting to say, oh, I got a formula sheet. The next exam is going to be easy. You should not let that thing fool you. It can fool you. It can be a wolf in sheep's clothing, a thief in the night, because you can think that it's going to be a lot easier than it's really going to be. If you don't know how to use those formulas, if you don't know how to use them in your calculator, if you don't know which formula to use in which situation, it doesn't matter if you have them. They are worthless to you. They might as well be hieroglyphics, something that you can't read or understand. By the time you are so well versed in these formulas and you're comfortable enough to use them effectively, you'll probably just accidentally memorize them anyways. But we do have the formula sheet for you. It'll be especially useful for Chapter 9, because in Chapter 9, we're going to talk about units and measurement, and you're going to have all the conversions you'll need in that formula sheet, like how many kilometers there are in a mile, how many inches there are in a foot, things like that. Some of them are easy, some are not so obvious. Like, I don't remember how many cups are in a quart of flour. I don't know that off the top of my head. I'll admit that. So you'll have a formula sheet for any conversions you need. Uh-huh. Uh-huh. Yeah, and growth. Well, and the nice, yeah, so section 8.2 is kind of weird because it gets really weirdly complicated. And after that, it becomes kind of a different focus. So we are talking about money now, but it's not going to be quite like how the tax section was. it's going to be a little bit different. So, but yeah, I understand that. There's a lot of confusing concepts in the tax section. Yeah, yeah, perseverance and putting that work in. Good work. So what we can do is we have a formula here that's going to tell us how much interest we pay. Let's do this instead. Let's look at this formula. This is the more useful one. This is the more salient formula. What this formula tells you is that if I borrow a certain amount of money, principal it's called, I have an interest rate R that's expressed as a decimal, and I borrow the money for T years. This formula can tell you how much is going to be owed after all that time. That's what A is. So capital A is the future value of the loan, or it's going to be how much is owed. If instead you're putting money away and you're getting interest from it, P is going to be the amount you deposit or put away into an account or even lend out to someone. A then is going to be how much money you're going to have after so many years. So let's break this guy down. Are you okay? This is your simple interest formula. A is going to be called, it's called the future value, but that can be, you know, that's what it is. But if you're borrowing, it's how much you'll end up owing. However, if you're gaining interest, if you're the one investing or putting money away, depositing it into an account, it's how much you'll have after so much time. It's going to be what the account grows to, the accumulated value. In fact, that's why they use a capital A for accumulated. So we're talking money. P, capital P is going to be your principal. That's going to be the starting amount in the account. Whether you're borrowing money, it's how much you're borrowing. If you're depositing money, it's how much you deposit at the very beginning of it all, at time 0. R is going to be your interest rate expressed as a decimal. T is going to be the number of years. So the A equals P, open a parentheses, 1 plus RT. This tells you how much is going to be in the account after so much time. Let's work an example from this. And then I think the best way to work sample problems is to go into your homework, because when I work the homework with you, I'm going to get different numbers than what you're seeing. So I'm not just doing your homework for you. I'm showing you similar example problems that are in the same vein of what you're going to be seeing. But it's still helpful. I think it's incredibly helpful. So let's say, let's have a fun example. Let's say, let's keep it simple. Let's say you borrow $7,000 for whatever reason. Maybe you're borrowing it to purchase a car. You borrow $7,000 to purchase a car for 5 years at 6.5% simple interest. Let's say you're not making payments or anything. You're just going to pay it back with interest at the end of the 5 years. How much will you owe? Now, this is not how it actually works. So what we're going to see is simple interest is an important type of interest to study, but it doesn't have a whole lot of use. It is not really practical, and we'll see why. Okay, well, obviously, we're talking about simple interest. The problem straight up states simple interest. If it didn't, then that would mean that you would be using a different type of interest, different type of formula, so that wouldn't work. So what we need to do is we use this formula. We need to identify what A, P, R, and T are going to be. So let's see, A is going to be how much you're going to owe back. It's the future value. That's what we don't know. So I'm going to put a big fat stinking question mark right there. P, the principal, that's going to be the amount that's borrowed. That's going to be the $7,000. R is going to be our interest rate. We're going to express it as a decimal. So 6.5% is going to be 0.065. And then finally, T is going to be the 5 years that we are borrowing this amount for. So we can now stick everything into this formula. Whatever we don't know, we'll just write in its variable. So we don't know A, so I'm going to write A equals P is 7,000, open parentheses, 1 plus 0.065 times 5. Hey, wait a minute. This is a calculator's job now. This is 100% the realm of a calculator. So pretty much going forward for the rest of this course, I would always have your calculator handy in class, whether you're coming to class or you are, in Zoom here, have your calculator handy. What are you getting? Okay, let's see. Let's see if you're right. Now, there's a couple things you can do. Technically, you can put this all in the calculator in one fell swoop. What you need to do is you need to do the 0.065 times 5 first. So let's see, 0.065 times 5. So you'll get 1 plus 0.325. 1 plus 0.0325 is 1.325. You're going to end up with, it looks like you had the correct answer. Very good. Need a little more space here. You're going to end up with, like you said, $9,275. Very good, very good. So this is going to be how much you owe in 5 years. Now, another question we can ask, so how much interest do you owe in total? Well, 9,275 is how much you owe. That is both the principal and the interest. So how can you figure out how much interest you owe? Exactly, very good. You take the total owed and you subtract the original amount borrowed, the principal. And that's going to give you, what is that? 2275. Yep. So This is going to be the total amount of interest. So you're going to owe the $7,000 back plus an additional $2,275 for the privilege of having that money for 5 years, because you took someone else's money and they didn't get to use it for 5 years. You would expect something back, wouldn't you? Absolutely. How many of you have ever lent money to a friend and you never got that money again? That money was gone. Anybody? Maybe you have, maybe you will have that one day. It happens. Now, you know, you don't know what situation your friend is. Sometimes you're okay with just letting them have some money if it helps them through a tough time. But the idea behind interest rates, the riskier a person you are, in other words, the more likely that the lender thinks you're not going to pay them back, the higher an interest rate they have to charge. The reason is that usually when you borrow money, you pay it back slowly over time. And if they charge you a higher interest rate, they're going to get whatever you do pay back, they're going to get some of that. They're going to get more than they would have otherwise. And then eventually, if you can't pay the rest of it back, then they've at least made something. So the riskier you are, the lower your credit score may be, the higher interest they're going to charge you. And they just have to. It's not that they're evil. It's just how risk and interest and economics work. Now, that does suck for young people. Especially people under 25. Your credit score is probably very, very low through no fault of your own. It's just because you don't have enough credit history, they call it. You haven't had enough time to go out there and establish your credit and prove that you are worthy of borrowing money and that you're going to pay it back. So that is the unfortunate truth. There are definitely some tips, though, that you can utilize when you are young to help build your credit score and have a nice, healthy one as you get older. And if you ever want to know, just ask. I can help you out. So now that's the basics behind simple interest. Now what I want to do is I want to work some more. So it says a loan of $1,060 has been made at 6.5% for 3 months. Find the loan's future value. So this one's interesting. T is supposed to be in years. So whenever we do T, I'll steal this. We're not going to put 3 because 3 months is not the same as 3 years. So a loan of $1,060 has been made at 6.5% for 3 months. So remembering our formula for simple interest. Let's fill in the variables from this specific problem, the numbers themselves. Now, we just did a problem with 6.5% interest. That's not interesting to us anymore. Let's change it to 4.23% interest. How about that? We're all throwing it in the calculator anyways. A is going to be the future value of the loan. They even use that term here. So we don't know what A is once more. P is going to be the principal of the loan. It's going to be the amount borrowed in this case, and it's going to be the $1,060. The interest rate is usually just told to you straight up. In this case, it's 4.23%. Remember, we need to express it as a decimal whenever we do the actual math behind everything. And now finally, T is tricky because we're doing this for 3 months. So is T equal to 3? No. Remember, T is in years. So 3 months, 3 over 12, 3 months is really 0.25 years. Keep that in mind. They'll try to throw you off with that. Now we can do the calculation. We can literally write 1060 times 1 plus 0.0423 times 0.25. we can even put that in our calculator all in one fell swoop. In fact, you can put it in the calculator exactly as you see it here. Use the parentheses around the 1 plus part. Do 0.0423 times 0.25. And it looks like you'll end up with, and you can round to 2 decimal places, 1071.21. Is that what you got? Very good. You'll usually round to 2 decimal points because we're talking about money. Sometimes it'll have you round to the nearest dollar, aka the nearest whole number. Just depends on what you see. Sometimes 2 decimal points is the key. Sometimes it'll say round to the nearest dollar. Just depends on what you have. Now this one, the interest wasn't so bad. The interest, total interest paid, well, we only borrowed for 3 months, so we aren't going to end up paying a ton in interest. Again, the longer you borrow for, the more interest you're going to pay. So if we take 1071.25 and we subtract off the 1060 borrowed, that's 21. Excuse me. That means we only had $11.21 in total interest, which for a $1,000 loan is not that big a deal. That's not going to break the bank. Usually, that's not so bad. Now, don't get thrown off. This formula right here, this formula is the whole shebang. Shebang is a non-technical term, meaning it's the whole thing, the whole ciabatta. Meaning, this tells you how much is owed after T years. There's another formula, in fact, we kind of glossed over it, where, what did they call it? I equals PRT. The total interest. P is still the principal. R is the interest rate. T is the number of years. This just tells you how much interest is owed, not the total amount. That's what that tells you. The reason I glossed over this formula is you could figure this out using the A equals P times 1 plus RT formula and just subtracting the principal from the final amount owed. That will tell you the interest. We just did it twice. So that's why I don't want to I don't want to give you too many formulas. You don't need 2 different formulas here if you understand how they're going. This formula is plenty to get the job done. Let's try out some other interesting things. Let's say you borrow $13,450, whatever. You borrow $13,450 at 7.25% interest and end up owing $22,345 when the loan is due. So you borrowed $13,450, you end up owing $22,345. Your interest rate is going to be 7.25%. How long did you borrow the money for? Round to 1 decimal. And one thing I'll mention, this is still simple interest, meaning we don't use a different formula that we'll be studying next. Well, our formula for simple interest still gives us everything we need to solve this. Write out what the variables are, and whatever you don't know, put a question mark. What is A going to be here? Exactly. That's going to be the $22,345 because that's how much you owe after the time has passed. What's P going to be? Exactly. What's R going to be? Perfect. 0.0725. You can put another 0 before the decimal point. What's T going to be? We don't know. That's the whole point. So I'm going to put a big fat stinking question mark on T for the moment. And now I'm just going to pop in what I do know into the formula. And here we may need to use a little bit of equation solving. Let's move things around a tad. $13,450 times 1 plus the interest rate is 0.0725. We don't know what T is, so I'm going to write it as the variable in there. And now I've got to try and solve this bad boy for T. Now there's a couple things we can do here to solve this. Remember, this is equation solving, so technically this is knowledge you'll want to come into this course armed with. Let's work it together though. What I would do is I would distribute this 13,450. And what you'll end up with is 22,345 equals 13,450 times 1 is 13,450 plus, now we need to do 13,450 times 0.0725. 0.125, very good. We get 975.125. And I'm just going to delete all this stuff. And don't forget, the variable T is still there. What can I do next? Well, here's my variable. Why don't we subtract 13,450 from both sides? Pretty standard equation solving. Again, you can use your calculator each step of the way, and I'm going to be honest, I'm going to use my calculator as well. It's not lazy to do it, it's that at this point, our numbers we're dealing with are going to get kind of nasty, and it's better to not try and do things on the top of your head. So now we end up with $8,895 equals 975.125 T. How do we get T by itself here? We divide. Yeah, we divide both sides. Yep. We would say, hey, divide this 975.125 there, Pilgrim. You're going to get T by itself. It'll be on the right. Normally, we like it on the left. But can't do much about that. And then we literally just do 88.95 divided by 975.125. We get about 9.1 1219, which we're going to round to 1 decimal point. So if we borrow $13,450 at 7.25% simple interest, and we owe $22,345, we must have borrowed for about 9.1 years, a little more than 9 years. Now keep in mind, this simple interest business, we're borrowing money, then we're paying the money back all down the line with interest, all at once. That's not really how loans work, is it? Most loans, maybe a loan with friends, you might do that. But most loans, what you do is you borrow the money, and then they're going to want you to pay back some of what you owe over time. So they're going to have you pay back, say, monthly payments. If you buy a house, get a mortgage loan, then they're going to say, okay, we just gave you $200,000 to buy a house. You don't pay us back after 30 years. You pay us back slowly, month after month after month. That's your house payment each month. Same for a car payment. So most loans in this country, in the world, you borrow money and you make monthly payments back at it. There could be other weird exotic setups. You can make quarterly payments, weekly payments, but monthly is usually the way to go. So simple interest is important to study to understand where other types of interest are going to come about, but it doesn't have a whole lot of practical, real world application, if you will. And that's also going to be true because simple interest has one fatal flaw in that the amount of interest you owe is only based on how much you borrowed. In reality, the amount of interest you owe increases as you owe more interest as well. It's called compound interest. So we will study that in the next chapter. Let's work one more. Let's say you borrow an amount of money for, let's make it interesting, 27 months at 33.45% interest and end up owing $123,000. How much did you borrow? I don't know what setup this would be. I don't know who would borrow a lot of money for that amount of time, that interest rate. That's a very high interest rate, even for simple interest. Right, so we'll have to convert that into years, exactly. And that's exactly what it'll be, 2.25. So let's remember our formula. A in this case, P, R, T. A is going to be how much you're going to end up owing, which has been supplied to us as 123,000. P is now what we don't know. We don't know how much was borrowed initially. R is going to be the interest rate. Since it's higher than 10%, it's going to be 0.3345. It's not going to be 0.03345. And then T, now it's 27 months. So it's not 27, it's 27 over 12, which you said would be 2.25. And that's exactly right. Yeah. And again, you can pop it into your calculator. Again, if you're given the calculator, it's just like the sweet and spicy bacon burger. It is something that has been given to you from on high, and the doves will fly out and the angels will sing, for you have a powerful tool in your hand. So don't try to do intermediate calculations in your head if you're not 100% certain. I use that calculator like no one's business. So it's so weird saying that because you're not supposed to teach math with the calculator because the calculator is doing the math, not you. But the problem is we're just dealing with numbers that are so complex, we can't possibly do them by hand, especially when we get to compound interest. So we make an exception. So we set up the formula, we plug in what we know. Whatever we don't know, we leave it as its variable. 1, it's always a 1 there. That's not a variable, it's the number 1. 1 plus 0 0.3345 times 2.25. Well, hey, the only thing I've got is P. To solve for it, I'm going to figure out what all that business simplifies to inside the parentheses. I'm going to do 0.3345 times 2.25. And I'm not going to round intermediate numbers if they're not horrible. So this only went out to 6 decimal points. I think you can just suck it up and write it out. If it went out to 10 decimal points, that means your calculator it actually probably goes out to way more than that, but your calculator has to stop. At which point you can just round. But here, whatever, it's not that big a deal. Then I'm going to add the 1 to it. So it's going to be 1.752625. So 123,000 equals P, the principal, times 1.752625. What am I going to do to get P by itself? Exactly. Exactly. I'm going to divide both sides. And long story short, I'm going to get the quantity of 70,000. You can round to the nearest cent, $70,180.44. So that's how much we must have borrowed, a little over 70 grand, to end up with 123,000 owed after 27 months at that interest rate. Okay. I think that